Hello, so we're continuing with the discussion on simultaneous equation. In the last video, I explained the concept of the solution to a pair of simultaneous equation. Now we're going to actually find the solution to an example pair of simultaneous equation. So let's start with the pair of equations 6x plus y equals 15 and 4x plus y equals 11. So these are linear equations with two variables. Okay, so this is a pair of simultaneous equation. Now, what it means is that if we graph them, we'd end with two lines that intersect with each other at one point. We are trying to find the coordinates of that point of intersection. Now, there are generally two ways to solve a simultaneous equation. One would be by elimination, and the other one will be by substitution. So we're going to talk about elimination method first. I'm going to discuss the steps one by one as I try to solve this pair of equations. So step one will be to balance the coefficients of one of the variables. Okay, what does that mean? So make sure that either x and y in both equations have the same coefficient. Coefficient would be the number in front of the letter. So in this case, we don't need to balance it because as you can see, y, both in equation 1 and equation 2, have the same coefficient of 1. So the 6x plus 1y equals 15, and then the other one is 4x plus 1y equals 11. So we actually can skip step 1 because we don't need to balance it anymore. It's already balanced. Now step 2 would be to eliminate the variable by adding or subtracting the equation. Okay, so since y is already balanced, that's the one that we will try to eliminate, and we eliminate that using two ways possible, by adding or subtracting the equation. So 6x plus y equals 15 and 4x plus y equals 11. So since they are both positive y's, it's easier to subtract. Okay, and so we subtract all the variables or all the like terms. So we have 6x minus 4x gives us 2x. So I'll write the answer in red. And then y minus y is 0, so that's going to be cancelled out, equals 15 minus 11 is 4. So our resulting equation now is 2x equals 4. Okay? And we proceed to step 3. Step 3 is to solve the resulting linear equation. Okay, so write it in red. So we have 2x equals 4. So just solve that. Again, divide both sides by 2. And we get x equals 4 divided by 2 is 2. So that's one of the coordinates. X is equal to positive 2. Now you have the value of x, you just need to find the value of y. And that would be step 4. Step 4 is to substitute the value found back into one of the previous equations. Okay, so now you know that x is equal to 2. You're going to go back to your previous equations 1 and 2 and use either of them and replace the x value with 2. So let's use equation 1, okay? So equation 1 tells us that 6x plus y equals 15, okay? Okay, so 6x plus y equals 15. Now, if x is equal to 2, then this will be 6 times 2 plus y equals 15. This will become 12 plus y equals 15. Okay, and now you just need to solve this. That's equation 5. Now, equation 5, step 5. Solve the resulting equation. Write it in red. So if it's 12 plus y equals 15, then you know, you've transferred that to the other side, y is equal to 15 minus 12, y is equal to 3. And therefore, you can conclude your answer. The solution is x equals 2, y equals 3, or you can write it as an ordered pair, 2 and 3. That's your final answer. That's the solution to your pair of simultaneous equation. Now, an additional step that you can do is to check, okay, if your answers are correct. So by substituting the solution to both equations and see if it's going to be correct. Okay, so for example, for equation 1, we have 6x plus y equals 15. Now, if x is equal to 2 and y is equal to 3, this should add up to 15. So 6 times 2 plus 3, because x is 2, y is 3, is equal to 15. That's 12 plus 3. That's 15. 15 is equal to 15. So it satisfies the first equation. Let's see if it satisfies the second. Second equation is 4x plus y equals 11. 4 times 2 plus 3 equals 11. That is 8. Plus 3 equals 11. 11 equals 11. So we can say that the solution 2 and 3 is correct because it satisfies both equations. And that's how you solve a simultaneous equation by elimination. Please feel free to pause the video at different parts to take down notes. So